with inflammatory processes that's also responsible for making HDL. And that's a whole other subject too. But anyway, the smaller and denser that the LDL particles are, the more likely they are to cause you problems. The big fluffy LDL is not a problem for anybody at any level. It's the small, dense lipoprotein little a that can clog the little channels in our arteries that normally are responsible for exchanging nutrients and waste products back and forth across that endothelial membrane. And that can clog things up and cause inflammatory processes that are associated with cardiovascular disease. Well, guess what? I mean, you never hear about lipoprotein little a from your doctor because statin drugs can't even touch them. What upregulates lipoprotein little a is the presence of insulin, in the presence, of course, of elevated carbohydrate. You take sugars and starches out of your diet, lipoprotein little a goes away. So excess insulin production from diets high in carbohydrates ultimately lead to insulin resistance, leptin resistance, and syndrome X, which is also known as metabolic disorder now. And this is just for starters. And carbohydrates eaten in excess raise levels of something called plasminogen activator inhibitor 1, which increases the risk of heart attack and strokes. These are all things that are very clearly associated with cardiovascular disease. Cholesterol is just a number. I see cholesterol as an indicator, and it's no more the cause of heart disease, as we all know, than gray hair is the cause of old age. But we can look at it. If I see elevated cholesterol, I'm not concerned about that in and of itself, but I am looking at other things in people's blood chemistries to figure out why that cholesterol needed to elevate in the first place. That's a whole other subject I could get off on, but I'm going to pull in the reins because I have a tendency to go over time. Advanced glycosylation end products. Tissue exposure to elevated glucose levels results in the production of this class of molecules known as advanced glycosylation or glycation end products, or AGEs. And again, that glycation process is something that glucose is a primary vector for in the bloodstream. And these advanced glycosylation end product molecules are proteins and lipids, again, that have become bonded to the sugar molecules in the bloodstream. And advanced glycation end products are well known for their destructive activities in diabetes, where they contribute to vascular disease, kidney failure, eye damage, and other kinds of dysfunction, including the nerve damage known as diabetic peripheral neuropathy. However, they also impair immune function in addition to damaging DNA and inducing mutagenic changes that can develop into cancer over time. They also serve to deteriorate the brain. This is one of the things, and as we age, the brain tends to shrink. And it's in proportion to the degree to which our brains have been exposed to excessive glucose. You see, our brains and nervous tissue really don't respond that much to insulin. So they're especially vulnerable to the processes and the ravages of glycation. The age-related damages to tissues involves a specific chemical receptor that responds to the presence of these AGE molecules by inducing inflammation. And that receptor molecule is appropriately termed RAGE, for receptor for AGE. And although the AGEs cause more rapid degenerative effects of diabetics, the same effects essentially happen in all of us to a greater or lesser degree depending on our exposure over a lifetime to glucose. So we can kind of, in a manner of speaking, all think of ourselves as being, to one degree or another, diabetic. You know, it's just a matter of whether this is happening in an accelerated fashion that's diagnosable, or whether this is a gradual decline that, that gets us as we get older, as our memory starts to go and our tissues start to malfunction. So relative to the progressive effects, again, we can all view ourselves as more or less diabetic subject to the same deleterious degenerative processes suffered by these populations, only to varying or lesser degrees cumulatively over time. Hopefully that gets you to think about it a little different. It sounds like an extreme view, but in fact it is, in a manner of speaking, true. So AGEs are essentially how we age. How do we avoid this? Well, the number one manner to avoid excess production is through the avoidance of all non-fibrous carbohydrate. In other words, avoiding sugar and starch. I mean, to my mind, because there is no human fundamental dietary requirement for sugar and starch, we just don't really have to have it. it's kind of a no-brainer to me. If I don't have to have it, if minimizing those insulin levels are going to help me function better and live longer into older age, and particularly preserve my brain function, which I'm relying on for my primary experience of life, then to me it's a small price to pay. And once you are able to metabolically adapt yourself to burning fat instead of sugar as your primary source of fuel, honestly, I'm telling you folks, you don't miss it. You really, you stop thinking about it. But of course the big problem is that people, you know, crave this stuff, and because of those addictions, you know, this seems like a really, really big thing. It seems like a big thing to have to give up. Yeah. Also, significant levels of blood glucose above homeostasis stimulate the release of insulin, the fat storage hormone, which works rapidly to remove glucose. Okay, body fat. And it's carbohydrates, not dietary fat, primarily, that make you fat. So I'm just giving you all the reasons you might want to think about applying what you learn here today. Insulin all by itself, of course, is known to have damaging effects on arterial tissue. In fact, people that are type 1 diabetics who have to inject insulin, you see around the injection sites tremendous amounts of scarring within the arterial tissue, because insulin is an extremely caustic, nasty substance all by itself, apart from the glucose. And here's an important point, because there are lots of people out there that seem to be able to get away with eating a pint of Haagen-Dazs every day and still looking like $1 million. You can burn off the sugar, but you cannot burn off the insulin. And every time you engage insulin in this manner, there is a cumulative effect over time that you end up paying the price for. You may look like $1 million on the outside, but I promise you that you're aging in ways you're not going to be happy about in time on the inside. Only in modern times, okay, have we actually created an emergency need to lower blood sugar. Our ancient ancestors ate diets that were primarily consisting of meat and fat, you know, and you know, during these long stretches of ice age, that was mainly it, was meat and fat. During more temperate periods, we had access to plant foods, and occasionally roots and tubers, but for the most part, our diet was pretty low in carbohydrate content, extremely low. Really, we think of insulin as our blood sugar hormone. It's not a blood sugar hormone. The management of blood sugar is really only a trivial side effect, a trivial thing that insulin does. We have several blood sugar hormones, but they all upregulate glucose. They're all designed to upregulate glucose. We have insulin, or not insulin, excuse me. We have cortisol, we have adrenaline, we have growth hormone, we have glucagon. All of these manage blood sugar in an upward direction during emergency states whenever needed. But only insulin's predominant function is really to take excess nutrients and put them into storage. Of course, every molecule that you don't, of glucose that you don't need right now for an emergency burst of energy pretty much can be considered excess, is going to be taken and put into storage. So insulin is going to primarily act upon carbohydrates. But excesses of protein and fats too can invoke some insulin response. It's just that insulin gets primarily associated with carbohydrate-related foods. But insulin's really in more recent times, because guess what? Yeast produces insulin. Tiny little worms, these primitive worms, C. elegans planaria, they produce insulin. They don't have blood sugar, because insulin is not necessarily associated with blood sugar. Insulin's primary function is really about the coordination of energy stores with reproduction and lifespan. And the most current research in human longevity studies shows very, very clearly that the lower the insulin, the less insulin we produce in our lifetimes, the less necessary insulin, the longer we live and the healthier we are by far. That it is primarily associated with aging and longevity and reproduction and lifespan. So we're very poorly adapted to this whole idea of having this emergency need to lower blood sugar. And I made this rather sorry-looking drawing in the last lecture here, but what this basically reflects here is, you know, we have a certain range of blood sugar that is sort of allowable, that our body recognizes as allowable. It's going to be a little different for different people. The functional range is sort of considered between 80 and 100 milligrams per deciliter. However, I actually consider an optimal maybe more like 70 to 85, but it's all in relative terms, because if you have somebody that's a diabetic and they're used to a blood sugar of 400 and you give them a blood sugar of 100, you can give them a seizure. So it's all in relative terms. You know, I could have a blood sugar of 70 and feel perfectly fine and be perfectly functional because my body isn't dependent on sugar as its primary source of fuel. So for me, low blood sugar is not a big deal. I have as much as I need. It's relative. But the functional general range for the average person is generally between 80 and 100. It's a narrow range. And if we exceed that range, or if it drops much below that and we're dependent on sugar as our primary source of fuel, we're in trouble. And so you get up in the morning, you eat that stack of pancakes, and you drink your orange juice and your chocolate milk and God knows what else that people do, Pop-Tarts, whatever. And what do you know? Zing, blood sugar shoots up over the allowable range. Well, your pancreas is going to kick out a bolus of insulin to deal with that. And it's not in a dose-dependent manner. It's really crude. It just dumps it out there to get rid of it, because it's damaging, it's glycating, you know, whatever else. And it's excess. And so insulin takes this and shoots it straight down, blows it past the level that the usual blood sugar hormones like glucagon and whatnot normally, which are normally designed to kind of edge this back up again, can handle. And now it's blown down into kind of a critical range where now there's not enough blood sugar to run your brain, to run your organs and everything else. And so what kicks in to save the day is your adrenals. And your adrenals fire to shoot the blood sugar back up again. Now you're back up here again, and on the way, you know, you're running to Starbucks to get that cup of coffee and the latte, and then you're grabbing the, you know, the muffin and candy bar or whatever that you're craving, and your blood sugar is shot back up through the roof, and now insulin comes back out again, and, you know, and on it goes. And people's moods and people's brain function and cognitive functioning and the neurological stability and everything else go up and down with these levels. And so many people are managing their blood sugar with their adrenals. This is not positive adaptation. I mean, this is survival. And your adrenals are your fight or flight organ. I mean, they kick out adrenaline and cortisol. That's fight or flight, and that's really only designed to be utilized in an emergency. And this, of course, becomes an emergency, but it's also a great way to burn out your adrenals. You know, for the women in here, you know, how gracefully you go through menopause is going to depend entirely on the health of your adrenals. And, you know, when your poor little ovaries are laying there like two little smoldering nuggets, you know, and they're taking their last gasp, and they're trying to pass the baton on to, guess what, your adrenals, to take over the hormone regulation and hormone production that they're supposed to kind of manage for the rest of your natural life. And they're laying there like two little smoldering nuggets right next to them. It's not a pretty picture. Just because, you know, hot flashes are a common feature of menopause does not mean that this is a normal and natural thing to have happen, just simply because it's common. It's also extremely neurodegenerative. I mean, there are a lot of bad things, bad things. And so we want to be nice to our adrenals, and we don't want to beat them up by asking them to try to manage our blood sugar for us all the time. But a lot of people live this way. So we're very poorly adapted to this modern need that we've created for ourselves. I mean, look at the stupid food pyramid. 11 servings of grains a day, you know. There's no human people group in the history of the human species that has ever eaten a diet remotely resembling what the USDA, U.S. Department of Agriculture food pyramid says is how we're supposed to eat. It's crazy. So, fats, not sugar, are really meant to be our primary source of everyday energy. Nature would never have been so stupid is to make us dependent on sugar for a